All right, Tony Mormino here with the Engineers HVAC Podcast, and we are here to educate and empower the HVAC community. So this is a live PDH event brought to you by Air Control Concepts and our family of brands. Excuse me a minute, this video is lagging a little bit. We'll give that a second. So we're glad you're here. We're going to get started in just a few minutes here. I got a great guest here, Tim DeStasio. Tim, how you doing today?
Oh, just fine. Thanks for having me.
Tim, I didn't catch where you were located.
I'm in coastal North Carolina in Southport, just south of Wilmington. Near
you're there. Okay.
The Oak Island. Yeah.
Gotcha. For some reason, I thought you were. Okay, I understand now. So we're both in North Carolina, so not too far apart. So, great. Well, thanks for joining us today. So, dehumidification is on my mind, that's for sure, because of all the stuff going on with the floods here. This video is lagging pretty bad. Courtney, how is it coming through? We'll give that a minute. So sometimes when we live stream, oh, Heather said it looks good. Okay. Sometimes when we live stream, the video lags, but I think it's coming through the other end pretty well there. So anyway, thank you all for joining us. We'll get started here in just a few minutes. We've got some very dramatic new movie music here or something. I don't know where that came from. Downloaded that from Adobe today. So anyway, what you're looking at there is footage of our office. That is actually my office, the home of the Engineers HVAC studio. Which was gutted out a little bit. So I'm in my basement doing this live stream. So we'll see how this comes through here. Hopefully it'll work out well for everybody. So, and we're gonna speak to the dehumidification aspect of flood recovery. We are not recovery experts. We are not disaster relief experts. We are somewhat air conditioning experts, I would think, and especially in dehumidification. And Tim does a lot of psychrometric training and online, and I do a lot of that too. So we're online friends. We've never met in person. That's a new thing, online friends. Right, Tim?
Yeah, it is new, but you get to learn about people's teaching abilities and their skills, and then when you finally meet them in person, you feel like you already know them.
That's right. It's so funny. I have friends that I comment with online. You're one of them, and other people, and I meet them in person. It's like I've known them for years. It's just a great way to build relationships these days.
Great community.
Yeah. So thanks for joining us, and this is going to be a PDH approved event. So afterwards, if we get through it all right, just email me and I'll send you the PDH certificate. So we're going to show a little footage while we talk. We're not going to have a detailed PowerPoint presentation. I'm kind of getting a little tired of PowerPoints. I think everybody else is. Sometimes when you're teaching psychrometrics, you really got to have one. But we're just going to have a general conversation here about what I've experienced in the last couple weeks here, and then a general, what is dehumidification? Like when we say dehumidification, what does that actually mean and how does it work?
Yeah. That's a pretty powerful dehumidifier that y'all have got set up now. Is that at the courthouse there?
So that one is at the Madison County Courthouse, which is a historic courthouse, and it's all wood in there. So they definitely need some kind of dehumidification help. I've learned a lot about some buildings may not need that strong of a dehumidifier, and some certainly do, especially if you got a lot of old wood, like a lot of old churches around here, a lot of old courthouses, historic buildings. And those are desiccant dehumidifiers. That right there is where my office is. And we looked at using a dehumidifier, but they chose to go with natural ventilation because the dew points here have been in the low 40s. And that building is all concrete and wood and steel. So
getting air movement. Just the last thing we want to do is lock up all that moisture in the wall cavity, and then it get cold, and now we're below dew point inside a wall cavity. There's no air movement. So air is our friend.
Air movement is our friend. I'm glad you brought that up. We'll talk a little bit about that too. And I had a guy comment on one of the videos I did, and he said, "Man, they're not removing the tile." I said, "I don't know. I'm not a restoration guy. I've just handled the dehumidification of the air." And he said that they pulled up tiles 3 years later and still see water on them after a flood.
Wow.
I don't really know how that's possible. I guess it gets really trapped in there, but
I guess, yeah.
Anyway, but thank you all for joining us. We'll get started here at probably about 3:02. We'll start the official PDH. So we're just kind of scrolling some B-roll here of what we've seen around the city.
Yeah. Is that still, that's in your office, right?
Yeah, so I clipped back from the office to job site visits, and there's a video we're gonna play in the actual presentation part. We start in a minute, and it's 20 minutes of just B-roll of us going around the city, showing the damage. And this, I'm just trying to do something that is topical based on what's happening in a lot of places. And, restoration came to my mind, but we're not restoration experts. So I was like, well, we could talk about dehumidification in general, and which is something Tim and I talk about all the time. And, having the foundation of psychrometrics behind that conversation is extremely important. I think that's why Tim does a lot of that training online, and me too. So,
yeah, I think having a foundation in psychrometrics also helps you be a better, that first response when something like that happens, like before the disaster companies come in, if you have a basic knowledge of psychrometric, you know what you got to do. And I know we're going to talk about that in the actual presentation, but you know that you got to get water out of there. You know that you got to get air movement. You got to get heat in there. You got to get some kind of mechanical refrigeration if possible. Just throwing whatever you can. And sometimes those first few hours are really, really important because they set the tone for the work that needs to be done later on. So you were at 24% right there in the video.
Yeah, that was.
Oh, yeah, that's an multimeter. That's just a hygrometer.
Yeah.
Back there.
He's calculating the grains there. I think we were at 8 grains supply air.
Okay, so that's coming from the dehumidifier. Yeah.
Yeah, it's coming from the dehumidifier. So one of the things they do, which is interesting, is you would think you'd pull the return through the dehumidifier, dehumidify it, and blow it back in. Well, the outdoor air is so dry, it's drier than the return. So we actually rolled up on a site with this beautiful, gorgeous, historic church in Biltmore Village, which was hit really hard. Like if you Google Biltmore Village, you'll see.
Oh yeah, it was terrible.
It was totally wiped out. There's some video in here on that, and we rolled up in there, and they were taking the air out of the basement, which was still had tons of water in it, running it through the deep. We're like, no, don't do that. Just use this outside air as your return. Because it's already at like it was like 40-degree dew point and 72. I mean, it's perfect. As good as you can get around here anyway for dehumidifying.
Yeah. Drier in, drier out. Yeah. I was just in Asheville a week before that happened. I was at the NCI, the National Comfort Institute Summit, and I met a friend and had a beer right there in Biltmore Village at one of the local breweries, and then I just saw pictures afterwards, and it's just crazy. I was just there. My parents are in Hendersonville. Their road got washed out. They live on the side of the mountain, so they got a lot of rain. They had one window leak, but they didn't have any flooding in their house. But no power, no cell service. I get one text a day from them. They're in their late 70s, so it affected everybody in different ways.
Yeah, it's been nuts. It's been nuts. We are, our town, Marshall, North Carolina, is right in a valley. I mean, it's literally like the perfect scenario for the perfect storm. And I was working Thursday, and the river was already, a lot of people don't know this, but we had like monsoon rains for 2 days before the hurricane was just like the tip of the iceberg. Before that, we had gotten so much rain, and I was sitting in my office on Thursday, and I was watching the water coming up, and the owner of our building, our landlord, is like, bro, what are you doing here? There's this flood coming. You better move your stuff. So we moved it up high. We're like, well, this stuff's 4 feet in the air. It's not going to get, well, it all got washed out. Except for what I have here with me, which is my camera and my mic and a few other things. But
good grief.
Yeah, it's great. Yeah. That's Marshall right there. That's downtown.
That's the bridge that you guys had to get off of because you were afraid it was going to collapse, right?
Yeah, our office is right to the right. It's off frame there. You can't see it, but we're lucky. Our home that I'm in now did not get touched. We're a couple miles up, so a lot of people lost everything they had, and that's another shot of the downtown. So we're going to go and get started here. So, Courtney, can you give me a thumbs up? This is coming through, okay? Courtney Sanders. Thank you very much. All right, we're going to switch over here. So we'll go ahead and get started on this PDH event here. So welcome to the Engineers HVAC Podcast, where we aim to educate and empower the commercial HVAC community. This podcast is brought to you by Air Control Concepts and our ever-expanding brands of operating companies. And thank you all for being here today. So I'm Tony Mormino. I'm going to be your host. And today we're going to talk about winning the battle against moisture after the storm. And I have a psychrometric expert here with me. And we're basically going to talk about, our expertise is in dehumidification, dehumidifying the air, okay, which is an important process if you get a natural disaster or a pipe burst or anything that brings a lot of water into your building. Drying it out is what I'm finding is a very crucial part of this whole process. This is a PDH type event here, presentation. So it's approved in most states. It's not approved in New York and New Jersey. We didn't have time to get that done. Sorry, folks. We'll try and get that next time. But anyway, so if you need PDH credits, just email me here. The email's on the screen there, tmormino@insetusa.com. If you're watching this in the future or listening to this on the podcast, you can check the show notes and you'll see my email on how to get the PDH credits. So, Tim, how are you doing today?
I'm doing great. Hope you are. I'm glad you're safe.
Safe and dry. I'm glad we have power. We didn't have power we were very lucky. We only lost power for about 5 days, but a lot of people went a lot longer than that. So I learned a lot about keeping carburetors ready. Or keeping generators ready.
Well, no, you were right the first time, because every time I've ever had to fire up my generator, it's been during when I lived in a little bit in the center of North Carolina and Greensboro. We'd get an ice storm every now and then. And the last time I fired up the generator was 2 years prior to that. And I was sitting there with a flashlight in my mouth, rebuilding the carburetor, cleaning it out.
Oh my gosh, dude, that was so me. It was crazy. It was so me. I would dip into it. I would try to get it started I had a fresh battery. I at least had that going for me.
Yeah.
And we would play with it for a couple hours and I'm like, dang it. And I'd go upstairs and I'd do something. And I was like, oh man, it'd be nice to have that power. So I went down. So it took us 2 days. I had to scrounge through a friend's shed to find some starter fluid. He had like a can with a little bit of starter fluid. And then we took the carburetor practically. Anyway, is this a carburetor presentation?
It's not a carburetor podcast.
I don't know what we're doing here, but I just went off on that. So I'm in Western North Carolina. And Tim's in coastal areas of North Carolina. So we were hit really hard with this flood, right? So, what's on our minds is we try to make these podcasts kind of topical and relevant with what's happening. So we're going to talk primarily about our expertise or experience with dehumidification. Just a clarification, we're not natural disaster experts. We're not recovery experts. I'm going to speak from my experience in the last few days, but part of the recovery process is drying out the building. And a very important part. So we're going to talk a little bit about what we see here, how that's done. We'll talk about refrigeration systems for dehumidifying, how that generally works, and then active desiccants, which are extremely common in these types of scenarios. So, Tim, why don't you tell people a little bit about yourself and what you do and your passion online? And Tim's kind of a troublemaker. He's an online troublemaker, I call him. So,
I am Tim DeStasio, and I'm an HVAC contractor. I started out in industrial commercial as a service technician, as an apprentice, got my associate's degree, went through high school and took their course, and then got my associate's degree in local community college, and started in industrial and commercial, working for a pretty large company that was based out of Greensboro, very well known in the area for many years. Then this is like the late 90s. And then as textiles left and manufacturing left the Southeast, their bread and butter became data rooms and clean rooms and pharmaceuticals. And so that was really cool. We pivoted to that. Around 2010, I got the wild hair that I wanted to own my own business. And so I went and got my contractor's license, and I started my own business and ran it for about 11 years. We did everything from industrial, commercial, all the way to residential. And when I sold it in 2022, that allowed me to kind of figure out, what am I going to do with my HVAC career? So I was, by that point, I think I make the joke that I've had 3 HVAC careers. I started out as a industrial technician, and then I was a contractor with employees, and we did everything from new construction to industrial service. And then this time with this business that I've started now, the North Carolina coast, I'm more of a HVAC designer, consultant, and a trainer. I also offer training services to HVAC contractors, just helping their technicians, their salespeople just understand the technical aspects a little bit better, which helps them be a little bit more successful. So that's what I'm doing now. My company is Comfort Science Solutions, and I do a lot of free online content. I volunteer my time in a lot of ways. And one of the things that I do is I make a lot of free online content. One of the things that I do on my YouTube page, which is Tim DeStasio HVAC, is I think you can see part of it in the background, but it's Psychrometric Saturday. And it's just a weekly series that I post on Saturday. It's a little 3-minute to 5-minute video just about something about psychrometrics. And we're 7 months strong now doing that. But I do that. And I also occasionally people will send me a reel or a video of somebody doing HVAC the wrong way. And usually they're very confident that they're doing it the right way. And the snarky side of me comes out, and I make a reaction video to that. And those get posted to Instagram and Facebook mostly. But that somehow has made me within this community a little bit more internet famous than I thought I'd be. Right. That seems to resonate with people. So we have a lot of fun. We ruffle a few feathers, but we try to educate as well.
No, it's great. It's a great way to educate and give back. And you do it in a way that's very professional and very like, come on, man, let's get it right if you're going to do this. And right. I'm just glad no one has sent you one of my videos yet. I'm waiting for that to come out, but it would be an honor. But, before we go any further, I wanted to thank, I got a little flustered at the beginning. Usually I call out, like we have all these people in the chat saying hello from where they're from. I usually do that, but I got so caught up in the flood footage and everything. But anyway, thank you. Everybody who's here. I see Stacy's here as usual. Thank you. And Courtney Sanders and Heather Robinson are in the background running the show. I forgot to mention that. So thank you all for doing that. And glad you're here. And thanks, Tim, for joining us today. Tim and I have been trying to hook up and get on the show. And then this flood hit. We had something scheduled. I'm like, oh no, we can't do it. And I'm like, wait a second, dehumidification, it's perfect. So okay. So we're not remediation experts. We already said that a few times, but I want to make that very clear. But I've been into the middle of this thing for about 3 weeks, and here's what I've learned in the process of when you go through one of these things. And I'm assuming the same thing as if you have a storm surge from a hurricane, or if you have a pipe burst or a main burst or something like that. Here it was a flood. So flood waters due to heavy rains. And so the process is you wait for the water to subside. You muck out the building. That's a new term that I've learned, which means getting all the mud out, getting all the stuff out that you're going to either throw away or dry. And usually the carpets, there's a big pile of it right there. And usually the carpet is something that's got to go. I haven't seen a building yet that's going to rescue the carpet because it's just, it's like a sponge. And pro tip, if you're going to take carpet out of a home or a office, cut it up in short sections, because wet carpet, especially if you're a little marketing guy like me, it's very heavy. So we learned that the hard way. And I got sore muscles where I didn't know I had muscles. So that's been what we've been doing up here. And but not complaining. I'm grateful to be in a position to help and to give back. So anyway, so you clean out the building. You disinfect it, which involves a whole other science. I'm not even going to get into that. I don't know anything about that. But you basically got to kill anything in there that you don't want in there. But then you got to dry it out. And maybe that's in the same simultaneous kind of process. But the drying out part of it's extremely, extremely important, because once you get past a certain point and the mold starts taking in and the fungus and the deterioration, it's really hard, from what I understand, to recover from that. So, Tim, what are your thoughts on all that?
Yeah, definitely. We want to get the bulk water out because dehumidifiers they handle water vapor. And so we want to, that's the war that we want to fight. Getting the bulk water out, and obviously waiting till it's safe to do so. And when we get a storm drains that fail, or a river that just swells up, there is no telling what is in that water that just ran through your building. I mean, there is, it's more than just dirt. And so we've got the disinfecting process is really, really important. But things that you can do early on just to, before the disaster companies get there, is doing exactly what you're saying. Start to muck out the buildings, start to get all that wet, destroyed stuff out of there, so that you don't have any of the growth that starts settling in. Once that starts propagating, it is hard to get out. And so if we can stop that process before it starts, all the better.
Yeah, for sure. And that's a volunteer effort, I have learned too. One of the things we learned, and you could see in that clip right there, the people in the PPE, that was us and the local community and volunteers. The one thing we've learned about this is there's no big cavalry coming anytime soon. So it's really important to be plugged into your community if you're in an area that might be prone to something like this. And I'm shocked at the level of, I don't know what the word is, but brotherhood or community that came together, at least here in Marshall. And I think that's pretty common in most communities in the US. And it's almost heartwarming to see it. We would go and we were working on our church, then we'd be done with that. And we'd go next door and work on whatever that was. And we just go down the street, and some people can't do physical work. So they're bringing food out and they're feeding people, and they're bringing PPE and they're doing stuff like that. So anyway, just a little bit of a side to that, but so cleaning the buildings out, crazy important. Then you got to decide what are you going to do to dry the building out, to dry it out, right? Tim and I were talking about this earlier. There's mechanical equipment like package DX type of equipment, which are mobile. There's desiccant dehumidifiers, which you're going to see a lot of those in these videos. We'll talk about that. And then there's the natural ventilation, some of these clips, I'll point it out when they show it, is the office, our actual Insight Partners office. But it's an old building that has a slab floor, concrete slab floor. The basement didn't get flooded. And it's got natural wood timbers in there holding it up. It doesn't have that many of them. And the rest of it's steel and glass and some sheetrock and 2x4. So they just cut out the sheetrock. And we let them borrow. We had a couple Insight Partners and Faulkner Haynes let them borrow some fans from our warehouses. And we blew that through there. And just the natural flow and the ventilation of the dry 40-degree dew point mountain air dried that out, right? So
yeah, stagnant air kills dehumidification or natural dehumidification a lot of times. It's interesting. You can make a little experiment. If you wet a sponge, you don't even have to saturate the sponge. You can just wet the sponge and you lay it on a table somewhere, and then you read the ambient humidity around that sponge. It's going to be pretty close to the humidity in the room. But if you put your hygrometer, your psychrometer, in a bowl with that sponge, you'll see the humidity rise almost instantaneously. And that's what's happening at a microscopic level on these surfaces with stagnant air, is that the water molecules lift up and they kind of just hang out right there. And they hang out in layers, and eventually you get enough layers and make a water droplet. But if you can get some air moving in there, then you allow them to leap off that surface, and then they ride the wave of air out. And so in the absence of any dehumidifier, just getting air movement is the best. A box fan, anything that you can do is going to help in those situations.
Yeah, open the windows if it's dry out too. Yeah, that's what they did in that building.
Definitely. Yep. Anything you can do. I mean, and that just goes into just regular keeping a building dry. Stagnant air is not good for human comfort. And so just getting just a little bit of air moving is all it takes.
100%.
Process. Yeah.
100%. And welcome Patricia, Robin, Mufti from Atlanta, Ryan, Christopher, Mike, Schoen from York, South Carolina. And then we've got Jason from Brooklyn, Michael from the Carolinas, Dan Myers, he's right down the street. Dan, I hope you guys are okay over there in Canton. Robert Swick from Atlanta. And then we've got Branson from Oklahoma City, Chris from Chapel Hill. And I'll say, I love to give these people a shout out because we're so appreciative when they come here. We love doing these online shows. So you all that come, and please ask questions too. If you have any questions, we're glad to answer. Someone had a tip about the generator, ethanol-free gas. So I have 20 gallons of ethanol-free gas labeled and dated because I'm like, I want to be prepared next time. But I'm so bad, I'll get all prepared, and then a year later I'll be like, we got a generator? What? Where is it?
Yeah. Even ethanol-free gas doesn't last forever. And
That's
so it
right.
never
That's
fails,
right.
but I never have ethanol gas when I actually need it. So,
That's right.
yeah. Anyway, we can start talking about generators all over again.
We could stay we'll do the second hour of generators, whoever wants to stick around.
Right.
So,
Yeah. There we go.
all right. So we talked about, the low hanging fruit, the natural ventilation. And, I tell you what, getting couple big fans in a generator is not that easy in a natural disaster either, because we couldn't, just driving around was hard because there's no, anyway. Okay. So natural ventilation. Now let's move into the mechanical types of ventilation where you're going to plug something in. It's going to really wring some moisture out there. But before we do that, let's talk about what is dehumidification? Like, what does that actually mean to dehumidify the air? Some people think, oh, I'm heating it up. I'm dehumidifying the air. I would say on Tim's, if someone sent that reel of me saying that to Tim, he'd probably be like, he'd do one of those on
Right.
there. So reheat does not dehumidify the air, right?
Right.
I'll let you go with that, Tim. You explain.
Yeah, well, I got the psychrometric chart, hand sketch psychrometric chart behind me, but what we teach in psychrometrics is that when you're dehumidifying, you're moving the dot down in the chart, because down means you're removing grains of moisture. And so when you're reheating, unfortunately, you're going from right to left or left to right. And
I got to do that all the time. I'll have my chart. I'll be like this. Okay.
And plus, it's backward. My feed, I am mirrored, so everything that I'm seeing is backwards. Right. But yeah, so we got to go down in the chart. We got to remove moisture, and so there's really two ways of doing that. We can do it through condensation, or we could do it through adsorption, not absorption. I've learned that. I was saying it wrong for a long time. But desiccant dehumidifiers use the principle of adsorption. But yeah, so we've got to wring the water out of the air, and I delve into a lot of mechanical dehumidifiers on the residential light commercial side. We don't do a lot of desiccant dehumidifiers just because they're not as practical in residential with small footprint units that need to fit in small mechanical rooms and stay there. But essentially with a mechanical refrigerant-based dehumidifier, we've got to create a cooling coil that is at a dew point that's much lower than the air that we're passing through it. But we're limited with the cooling coil on a refrigerant, or really, and even a chill water coil. We're limited to keeping that several degrees above 32 degrees, because at 32 degrees, any condensation is going to start freezing up on the coil. Then our coil becomes very ineffective very, very quickly as soon as we get the first little layer of frost. So it works really well for comfort cooling, because essentially your air conditioning coil, your chill water coil, is going to be somewhere around 40 degrees, give or take. And so we're able to wring a good amount of moisture in certain conditions that are conducive for comfort cooling by using a refrigerant-based dehumidifier. And then the other limitation to a lot of dehumidifiers is what happens when we bring in air that's warmer than what that dehumidifier was designed to, air that's more moist. All of a sudden, we throw a bunch of BTU load, whether it be sensible or latent BTUs, onto that coil, and that coil temperature rises. And so we're still doing dehumidification, but we no longer have a 40-degree apparatus dew point, which is kind of the average cooling dehumidifying coil temperature. We use that term. And when that happens, your typical household dehumidifier does not have any way of bringing that coil temperature back down when it sees that load. It doesn't have a thermostatic expansion valve. It doesn't have an electronic expansion valve. It is just a fixed orifice meter device. And so when it sees a lot of load, the coil temperature goes up. And so you're leaving grains of moisture. Your leaving dew point is now higher. And so if you just continue that situation, just pulling in too hot, too humid air, you're never quite going to get there in comfort cooling. So sizing and making sure your entering air temperature conditions are right with a refrigerant-based dehumidifier is really, really important. With desiccant, and I don't have as much experience with desiccant, but desiccant is really, really cool because you aren't as reliant on your incoming air. I mean, it is important, but you can manipulate your vapor pressure by adding heat. And so it allows you to dehumidify in conditions where a refrigerant-based dehumidifier normally would not be very effective. The downside is it takes a lot of energy. to heat that air up, or to heat that regeneration cycle, so that we can release those water droplets. But yeah, I've been doing a lot of research on desiccant dehumidifiers, because I do think that there is a use for them in residential, but it's very, very limited in light commercial. And it just seems like the wheelhouse of refrigerant-based dehumidifiers seem to be right there in comfort cooling. But it's a really cool technology with using a silicone wheel, or is it silicone or silica, Tony?
Silica.
Silica.
Yeah.
That it just kind of grabs those water molecules, and it wants to hang on to them until you throw some heat at it, and then it can release it.
Yeah, for sure. They have a great capacity, moisture removal capacity per kW input and square footage. And, one of the things I was thinking when you were talking about DX is, a lot of folks have the idea of, once the power comes back on, and I saw this in a few buildings, they closed up the building and they cranked the thermostat way down on a standard type AC. And that is like, I'm telling them, I'm like, dude, don't do that. You're going to grow fungus in here. If you want to do that, open the windows and open the door. Here, if the conditions are right outside, like for our building, we had fans blowing through it. It was 75 degrees, 45 degree dew point, and they had the air conditioner on, but not like cranked down real low. And I think that was the perfect thing to do. I'm like, okay, whatever you do, don't close this up at night and crank this AC all the way down and leave it at night, right? Like, we had a lot of solar load. We had the fans blowing through, so the air was coming outside. So you know what I'm saying? What do you think about that scenario?
Yeah, putting some artificial sensible load back into the building is really important. The thing about refrigerant, or I guess DX, or any mechanical dehumidifier that uses the refrigerant, is that we first have to cool the air to get it down to dew point before we can start wringing the water out of the air. And so we're getting this unwanted byproduct of dehumidification, which is cooling. And it's unwanted in the what I mean by unwanted is that we are not looking to cool the air down. Once we cool the air down, we're actually hurting the relative humidity, because, as we know, the relative humidity, when temperature goes down, relative humidity goes up. And so having some way to put heat back into the building somehow, and that's where reheat comes in, is really essential. And that's what a refrigerant-based dehumidifier does, because it puts the condenser in front of or after the evaporator. So we're taking those same BTUs that we took to not only cool the air down to dew point, but then to be able to get the latent heat out of that air and drain that water out. All that energy next gets transferred to our condenser coil. Plus, we have the heat of compression, the kWs that the compressor is consuming, and all that turns into sensible heat that we can put back into the building with a dehumidifier. We're not wasting any of that energy, as opposed to just turning on the air conditioning. If we turn on the air conditioning unit, yes, we are cooling the air down to dew point. Yes, we're bringing the dew point down because we're wringing the water out. But then we take all those BTUs that we've absorbed in the refrigerant, and we send it outside and reject it. And that's great when we're trying to cool the building, when we're trying to dry the building.
Right.
We actually need that heat. So what I've done, for example, our building that we have our religious services in, it's the air conditioning units are sized for a full house. And then we get all the moisture that we had dumped in the last couple of months. And there is extended unoccupied periods. And I was seeing 70% humidity. And so what do? Well, we can go to the local hardware store. We can start getting some little portable dehumidifiers. But the other thing that I did is that the biggest dehumidifier you have in your building is your air conditioning unit.
That's right.
And these were air source heat pumps. So I had two choices. I said, well, I can turn on the electric or stripped reheat and jump them out so that I can throw in some heat into the building. What I ended up doing is putting them on a schedule to alternate, and one unit heated while the other unit cooled.
I love it.
Because they both serve the same auditorium. And so and what I did was just maintain around 72 degrees. And our energy bill that month was really, really high, but water and moisture is a form of energy, and it takes energy to remove that energy. There's no free lunch here. But we had to
Love
do
it.
that. A mold remediation would have been a lot more expensive. So there are little tricks you can do to throw some reheat in there in the absence of equipment that's dedicated and designed for that.
It's funny you say that. I had a home in Florida. It was 2 stories, and we had an AC upstairs and downstairs. And sometimes I would come home, and the heater would be on downstairs, and the AC would be running upstairs. I was like, "Oh, you
Yeah.
guys are drying out the building today. Thanks, drying
Right.
out the home." But I never thought of
Yeah.
that for churches. This is it plays right into this discussion of,
Yeah.
we've done many presentations on, in my opinion, not understanding what happens at part load is probably the most dangerous thing for a design engineer to not understand, because you get in so much trouble. And once you have those kind of problems, it's really expensive to correct them unless you get really lucky. Like, I could think of one of the jobs that comes to my mind. We had this cafetorium. It's a cafeteria. One day it's an auditorium, the next day, and there's a lot of outside air. And it was in Jacksonville, Florida. Your total nightmare from a dehumidification standpoint, right? Because it's 25 tons one day, and the next day it's 5 tons, and it's October. And it's wet, but it's cool out. It's 68 degrees, but it's rainy. So like the perfect storm, and you still got to bring in enough outdoor air, yada, yada, yada per code. So I remember going to that job site, and the GC was like, "Hey man, your unit's not working." I said, "It's not?" He said, "Well, feel how humid it is in here." I said, "Okay, where's the humidity sensor?" He goes, "Well, it doesn't have one." I said, "I know, because it's not controlling humidity. It's controlling temperature." Right. So that's a big thing, is like, what? It doesn't. It does dehumidify as a byproduct of looking at the sensible heat in the space. But if it's not set up with hot gas reheat or variable speed fans or something like, so that particular unit had a variable speed fan and a variable speed compressor. So we changed the airflow based on the temperature in the space. So it would provide 50-degree air, but it would be at 20% airflow. So it would constantly be stirring and dehumidifying the space. But part load is a killer.
Yeah. And, even like this time of year, of course, we just got into some cooler, drier weather, but it just happened in our area, like in the last few days. But sometimes it does make sense to bring in that drier air from outside when trying to fix a problem like what y'all are dealing with. Sometimes it doesn't. And so you may have to plot your 2 points on the psychrometric scale. Okay, it's 80 degrees and 70 degrees dew point inside, and it's 90 degrees, but 65 degrees dew point outside. Well, technically it is a little drier outside. So
that's right.
Maybe I can get away. But if it's not, if you got more dew point or more grains of moisture, whichever side of the cycle chart you're looking at, then you aren't doing anything. Even though it may be warmer outside, you also are actually bringing in humidity. Another lesson I kind of learned the hard way is that I've always had a bunch of window units for my contracting business, because we would run the situation dead of summer, someone's air conditioning goes out, and we just couldn't get to them as fast as possible. And so we could throw in an AC unit. I was able to keep them going, and I didn't lose the job. So I have all these AC units around. And so at one point I thought, well, let's, in a case of, whatever, a water disaster, let's just get an AC, a window AC, set it on a counter, and let it just do its thing.
Wow, I love it.
But
is you rejecting the heat in there?
The thing is, you're rejecting the heat. The thing about window ACs is part of the way that they get rid of the condensation. If you notice,
they sling it on the condenser coil.
They're slinging it on the condenser.
That's right.
Then that gets absorbed. So you got a net zero effect. All you're doing is adding some sensible air. So it sounds good.
Wow, what a great psychrometric example.
Exactly. So what you end up doing is you tilt it so that it actually drains out, and then you're getting rid of that condensation instead of slinging it back into the air.
Oh my gosh! So you actually had a hack. So if you're listening to this and you didn't know, there might be a lot of people listening to this that don't know that, but typically. And even I think for small dehumidifiers, like we have one of those little portable ones, you put it in a space. I think you do have to empty the drain pan, but I think it does sling some of that on there too. But that's still funny.
Yeah. So anything you can do if you don't have that professional disaster dehumidifiers and blowers is get air moving in your house. Turn your ceiling fan on, turn your AC on, turn your oven on. Like, get some
Hmm.
heat and some mechanical dehumidification in there. Be prepared to spend a lot in energy that month. But that's things you can do. There's already a lot of sensible heat. If this happened in the middle of July, and you probably have enough sensible heat to not have to turn on the oven. If it happens in October, or late September, like it happened here, then you may have to
Yeah.
create some sensible heat to keep that AC running. So
Good stuff. So yeah, so that's, one of the things too, like we were talking about mechanical cooling, unless you have reheat, you get that cold air in the space, which really is not good. You don't want the
right,
surfaces to be cold. So we could switch gears and talk a little about these. I've learned a ton about desiccants. I've been a big fan of desiccant units for my, in the couple decades I've been in this business, and for the right application, right? If you got a general office space, it's overkill. If you got a school, well, you might use it for the outdoor air, but generally speaking, mechanical cooling DX with reheat is great for humidity control. That's probably 95% of what we've done in our career.
hmm
But you got that 5% where you need lower dew points. So if you need lower dew points, lower than 35, maybe even 40, start considering a desiccant, because you know the amount of money and gear you have to do to get below 40 every degree is very expensive. It's like
yeah,
it's an exponential relationship. It's not
there's
a direct
diminishing
relationship,
returns.
right?
Yeah,
Because you're starting to you're squeezing every bit out of it. And
yeah,
desiccants are amazing because you put heat on one end and you dries out the air on the other side. They're
yeah,
really nice when you need them, right? And
yep,
these are great applications. And the reason you see so many of them on these videos is they have a very high capacity for moisture removal in a small footprint. There's some duct work out of a home. Looks like a gas burner there, doesn't it?
yep,
Um,
yeah,
this footage here is from the Biltmore Village, by the way. If you're watching and want to see, some really bad devastation, that's where that was there. That's actually the
yeah,
back end. This kind of switches over, but that's my office, or where my office is.
yeah,
But anyway, active desiccants, you have to have a heat source, and to run that
yep,
heat source, and if you don't have gas, which some places, I didn't see any that had gas. Some places probably do, but you have to have electric strip heat to dry the wheel.
yeah,
If you got electric strip heat, you better have a lot of power or a generator. So the caveats um, to running a active desiccant dehumidifier is you got to have a way to power them, because we're actually going to get one of these for our office building. I was talking to the owner, and I have a relationship with the manufacturer. And I'm like, oh, let's get one. And he goes, well, what are you doing for power? And I said, oh yeah, how much power does the 5,000 CFM unit need? He goes, well, it needs a diesel generator, 150 kW. And I'm like, whoa, that's a big. I got a 3 kW generator, like the one I couldn't get started, right? So these are big
yeah,
behemoth generators. By the
right,
way, that 150 kW generator uses 10 gallons per minute of diesel, 10 gallons per hour of diesel. And then, by the way, you need your DEF fluid. So you can see by these generators, there's like a
yep,
pile of diesel exhaust fluid sitting there, boxes of that. So it's a
yeah,
big, it's a big deal is what I'm trying to say. Like if you're going to
right,
dehumidify a space with one of these, and
yep,
like that right there is the courthouse. Like if you drive straight over that bridge, that's the Madison County Courthouse. And a lot of the footage on here shows the two portable desiccant units that are drying out the air that's going into
yep,
that building. So you've got the dehumidifier. And what happens is, and if you're watching this and you're an owner or you're an engineer or somebody who needs help with this, you call one of these big rental companies. Okay, I'm not going to call them out because this is a PDH deal. I want to keep it neutral, but you call one of the big rental companies. They do it turnkey. Like you don't have to go out and piecemeal, find the generator,
yep,
find find the fuel. They'll come, they'll park it there, they'll set it up, they'll monitor it, however you want
yep,
to do it. The good thing about the desiccant is it gives you extremely low dew point, but it heats the air. Part of the process is you heat the air. So you're
hmm
getting 90-degree air at 8 grains or something like that, which is like that's heaven for dehumidification because you're actually heating up. So what
yeah,
happens is you take this air, let's have the discussion about where does the air come from, right? Are you pulling it from the building? Maybe. Or are you pulling it from outside
right,
that's, in our case, 72 degrees 40% dew point, that's going to be drier than the building. So what you do is you actually just take the outside air, run it through the desiccant wheel. So if you got 28 grains outside, you might leave at 8 grains, but you're leaving at 90 degrees too. So what happens is you're blowing this dry, hot air into the space, and it's like a sponge. Due to vapor pressure, it's going to suck the water out of your furnishings, your floors, whatever you have, any kind of wood in the building. And it's warm. It's going to actually heat those surfaces too, which helps with the evaporation. So, that's why people use them, because of their massive capacity to remove moisture, and it heats the air as well. So
it's really amazing. I'm converted. I'm a dew point guy, so I don't think in terms of grains. I think in terms of dew point.
Yeah.
And so you're saying 90-degree dry bulb and 8 grains is the leaving air temperature or condition. That's a 7.2 degree dew point,
Very
which
low.
is crazy low. You are going to start making those moisture molecules jiggle, and when they jiggle, they're gonna leap off the surface and they're gonna leap into the air, and then they're gonna ride the wave out, which is what we want. And that's where a desiccant dehumidifier shines, is because you'll never get that out of a DX dehumidifier at all. When you're dealing with, let's say, a 40-degree cooling coil, dehumidification coil, the best dew point you can expect leaving it is 40 degrees. Theoretically, you can't get any lower than that. Realistically, you're probably looking at around 50-degree dew point coming out. So if you're trying to control a space to less than 50-degree dew point, and the dew point of the air that you're feeding into that space is above 50 degrees, you'll never get there. But you can with desiccant. And that's why, in your clean rooms and your hospital environments where they have to have that ultra low dryness and even cold temperatures, mechanical refrigerant base dehumidifiers is just not the application. So it's really cool stuff. The more I learn about desiccant dehumidifiers, is the more I love it. We're seeing, of course, we've seen desiccant dehumidification in ERVs for a long time, HRVs, but mostly ERVs, because ERVs actually grab onto some moisture, but ERVs don't have that reheat capability. And so we're relying on the difference in humidity from inside to outside. And what I tell people in residential is there's a myth I think some people have, that if they have an ERV, they don't need a dehumidifier because the ERV wheel has a desiccant material, but it is simply not grabbing enough grains of moisture to do the job. And so you still have to have dehumidification.
100%. That example I said earlier about the cafetorium, that had an energy recovery wheel, and the misconception was there that I'm like, look, it saves energy. It doesn't dehumidify your space because the leaving air off of the wheel is higher than the dew point of the space, so it can't possibly dehumidify. But I was just going to show this, like we were talking about the setup. Let me see if I could find this part of this video. So this is Marshall, North Carolina, and give that video a second to catch up. So this is the other part that was hit real hard is called the River Arch District, near downtown Asheville. This is a brewery called the New Belgium Brewery. And I was actually...
Oh, that's New Belgium. Oh.
Yeah, they've got, I don't know, they must have, I bet they have 30 of these dehumidifiers there. There's the whole facility. It's right on the river.
Yep. And I was worried about them because I know they're down low. You're looking down at that brewery when you're driving into town.
Exactly. Yeah. So if you drive into town over the bridge, if you look to your right, you see it there. It's right on the river. It's a gorgeous facility. And this is a typical setup. I was actually there. I was actually in Asheville looking for temporary office space. And I'm like, you know what? That's pretty far. I'm just going to stay here right here in the old bunker here. It's pretty good.
Yeah. Yeah.
But that's a typical setup. So in that scenario, you have 2 dehumidifiers and then the generators to the left. They're pulling their return to those units from the space. I'm not sure that's a good setup, but I'm not an expert at that. They probably have a reason for doing that because it's so dry here. I'm not sure that provides a lot of benefit. The other thing I was going to point out too about these systems is like this. So this jumps over to a couple systems we saw. Ooh, that's a good view right there. I almost got it, but see that filter up top, how dirty that is? You better have a truckload of filters, because what I've learned is when you're in this floods or any kind of disaster recovery, when it recedes, it's like I'm wearing a mask there for a reason. I mean, there was powder everywhere.
Yeah.
Right. And those are 5,000 CFM units. So there's an air on the reactivation side, and there's a filter on the reactivation side, and there's a filter on the outdoor air side. And they every one of them I saw was pretty darn dirty. So shipping them with a box of filters is probably a good idea.
I gotta imagine that if you are pulling in outside air on the desiccant dehumidifier instead of pulling return air, you probably need to have some bay doors open to relieve, because you're pressurizing that building. You got to have somewhere for that moisture to leave the building. But I think there is a case though, and I've thought about this. I need to do the math on it with any kind of dehumidifier. You also want to let the big dog eat, and you want it to see the load. So like when we're designing for air conditioning systems, like for commercial buildings with a lot of load on them, sensible or latent, if you can put your return right there above where that load is, I want that system to see it. And so there's probably a threshold where it's no longer feasible to pull return air from the building, and now it's better to pull in outside air. But I know that there probably is some benefits of pulling in that, sucking that humid air, and just being able to grab those water droplets and get rid of them. Do those desiccant dehumidifiers, do they deal 100% with water vapor? There's no drain line on them, right?
There is not.
Yeah, right. So you're dealing,
it's all vapor.
You're just dealing with massive quantities of water vapor.
I think some of them do have a drain for certain conditions, if it's really cold or something. I don't remember. For some reason I think they do, but it's not. No, it's not. They're not dropping air. The exhaust part of them feels exactly like a dryer vent. Yeah. And if some of the videos, on our YouTube channel, I'll put up a little QR code if someone wants to go watch those later. But we take the measurements to show, the moisture it's wringing out on the regen side, or the reactivation side, it feels just like a dryer vent. So you could tell, just feel how
that hot, wet dog's breath kind of air coming out of it.
Dog's breath. Does feel like dog's breath. I never thought of it that way. Feels like dog's breath, but that's some other shots of the city there. But
wow.
Yeah. So learned a ton. Yeah. And there's a shot of another unit on that church downtown, the Biltmore Village. Beautiful old church. All wood floors, herringbone, and all these amazingly nice wood features in there. But anyway, that's perfect application for that too, because you really got to that whole area was completely underwater, 4 to 6 feet. It was nuts. But,
it takes a lot of energy to do what they're doing there, and so in a temporary emergency situation, it's all hands on deck. Then that you do what it takes. Obviously, in that case, that's not a sustainable way of drying a building out, just because of the amount of gas and generators, the amount of energy it takes to go in there. That's where, again, refrigerant-based, when you get that coefficient of performance, now you got a force multiplier in there that refrigerant allows you to have, where you're not consuming you're consuming 100% of your electrical energy, but you're getting 300% out because of latent heat of vaporization. But in this case, you got to dry that building out in a hurry, and the refrigerant-based dehumidifier is just not going to get you there, especially when we're getting cold temperatures like now.
100%. This is actually this unit here is a unique one because it comes with a gas tank. There was a propane tank on the front of it, so you only need like a 20 kW generator for this particular unit. It's a 2,000 CFM unit, so if you have a smaller building, now I don't know how much propane it burns through. It probably uses quite a bit, but at least you don't need a huge generator. The other part of the power too that needs to be paid attention to is their 480 volts, 460 volts. So a lot of churches and office buildings they may not have that available. So that's another thing to just be careful of there. So
Yeah, the amount of air
so this
they have
is
to
good
move is
stuff.
amazing. Yeah.
It's crazy. It's crazy how much moisture they remove. But hey, Heather, if you don't mind putting up the PDH email, just give a shout out for that real quick before we finish up. And I wanted to say thanks to Jeff from Orlando. We got Alan from Des Moines, Jeffrey with the advice, run with ethanol-free gas. Thank you. Robert from Atlanta, Luke from Kalamazoo, Michigan, Tugsy, I hope I'm saying that right, from Orlando, Florida, Barry from the North Georgia mountains. Sam Braddock says, Tony, thank you for the shout out. And I am glad to be back in the saddle and doing this thing. And, the show must go on, right? We can't stop. And especially when there's a lot going on that, makes the content more valuable. And by valuable, I mean, hopefully we're helping some folks and giving back and trying to be of service here when we can. And, I was thinking about what we could do from a podcast standpoint. So I hope this does provide value for some folks. It's going to live on our YouTube channel, which is HVAC TV, and on our podcast. We'll put an audio version on this on the podcast, which is the Engineers HVAC Podcast. If you need a PDH certificate for this, please reach out to me. The PDH information is below. Tony Mormino at insightUSA.com. I forgot my email address for a minute there. What's going on? I'm like 53 and I'm already forgetting stuff. If you're listening to this in audio version, you could just check the show notes there and we'll have that in there. So what do you think? What else do we need to cover? Did we forget anything, Tim?
I think it's we can talk about forms of reheat when we're maybe not talking about emergency dehumidification.
Yeah.
Regular, because if you have we know why we need reheat and regeneration heat with a desiccant material. We're creating pressure by manipulating temperature. So I'm a refrigerant cycle guy. That's where I came up as an HVAC technician. And so we have to manipulate pressures in the refrigerant to manipulate temperatures. And so with a desiccant dehumidifier, the way I got my brain wrapped around it is that we're doing it but backwards with desiccant dehumidification. We have to manipulate the temperatures to manipulate the vapor pressures of that water. So that's where that heat is really important. But when it comes to refrigerant-based dehumidification, if we simply just cool the air, we've talked about it, we're going to overcool. And so with some office building residential strategies, you'll just have your air conditioning unit and the thermostat will say, well, do you want to enable dry mode? And mini splits have dry mode on the little remote control. And here's the big secret about that. The only thing that they're doing is allowing you to cool your building down 3 degrees past the set point before it actually shuts it off. And so it's not doing a whole lot. You can do that by just setting your thermostat 3 degrees lower than what.
There's no reheat in there.
No, there's no reheat. And with mini splits, many of them, I have not seen one dry mode yet that actually does anything like slow the blower down to increase the compressor to get a little bit lower of a coil temperature. And they're not doing that because everybody's chasing a SEER rating now, especially with residential equipment. So I know your audience is mostly commercial engineers, but we all got homes. And so we got to think about how are we going to dehumidify our home. A whole house dehumidifier, something that you would see from, I'm not going to name any brands, but we know what those look like. They're all packaged together. They have the reheat coil built into them. They're going to add some sensible heat into the air. But typically when we're using these, we're not using them on a peak design temperature day. We're using them on a peak design humidity day. And so we have a little bit of sensible capacity to spare there. So we're not going to overload and not be able to maintain temperatures. But on your part load days, you've got to have that reheat. Now, I've been messing around with a Wi-Fi controller. It's against code to do this. It's against ASHRAE, can't remember what ASHRAE standard, but you can't use electric reheat on commercial buildings. But my little residential unit, I came up with a Wi-Fi controller along with my ecobee thermostat where I can dry my house using the heat pump compressor, and I use my electric strip heat to do a little bit of reheat. And it does make my energy bill go up. I've been tracking it all year. My home energy bill, the difference between having a dehumidifier strategy versus an electric reheat strategy, one half of the month I do one, the other half of the month I do the other. Then I normalize my bill, and so I kind of know, okay, well, my bill would have been this much this month for one versus the other. I'm up to around $600 difference. But the thing is, you can turn your AC if you have an air source heat pump with the reheat, electric reheat after the cooling coil. You got to be after the cooling coil; it can't be before it. Then you can turn your AC into a dehumidifier, but it's going to cost you.
That's right.
There's no free lunch when it comes to that. So really the best kind of reheat is going to be hot gas reheat because we're taking that BTU instead of throwing it away and losing it forever. In the condenser coil, we're actually using it to reheat the air. And then after that, maybe it's gas fired. And then finally, you get to electric strip heat where you only have a 1.0 COP. That's probably the worst way to do it, but it's the easiest way to do it on a residential home unit because everybody's heat pump has some heat strips that are sitting right there in front of the blower. So just some tips for everybody that has a house. You can turn your AC into a dehumidifier if you tinker around with controls enough.
We used to sell kits when I started in the industry, commercial kits to convert your unit into a dehumidifier in a commercial building if they had units, and it's basically doing what you said, but now we can't do that with commercial buildings anymore. So if you're smart like Tim, you can figure it out in your home and, hope the KW police don't come knocking on your door or something. But
right. Well, when you think about the standard dehumidifier installation, when I do one for a house, it starts at $5,000. You can buy a lot of electricity for $5,000.
That's right.
So
they're not cheap.
It'll get to have a bind if you need to. So for what it's worth.
Awesome. Well, Tim, thank you so much for joining us today. I hope you enjoyed it.
I did.
I enjoyed having you. We'll have to do this some more. What's your YouTube channel, Tim?
Tim DeStasio HVAC. I'm going to just let the camera go up a little bit. Tim DeStasio HVAC. You can find me on LinkedIn.
There's your name there.
Camera's going to find me here. LinkedIn, it's Tim DeStasio. There is a space on LinkedIn between the DE and the capital S. So DE space Stasio. And then same thing, Tim DeStasio HVAC on Instagram and Facebook. That's where I post the funny stuff.
Awesome. Well, thank you, Tim. Thanks for giving back to the community. And thanks for being on the show. And thank you all for watching today. We greatly appreciate you. And we hope we'll catch you on the next one. Tim, will you hang out for a few minutes with me?
Absolutely.
All right. I'll see you in a minute.